LJ Institutes of Engineering and Technology. In the current video lecture series, we are studying the subject of Physics Group 1. Today, we are going to start a new chapter, that is superconductivity. In the today's video, we are covering the topics such as introduction to superconductivity, discovery of superconductivity, and few important properties of superconducting materials. So, let's start with the first topic of today's session, that is introduction to superconductivity. But before moving further, my question to you is, what is superconductivity? Okay. So in order to understand about superconductivity, we must understand first of all what are superconductors. So a superconductor is a material that loses all its resistance to the flow of electric current when it is cooled below a certain temperature called the critical temperature. You might be aware about the resistance. Resistance is inversely proportional to the temperature for the case of conductors. Okay? In the case of conductors, what happens when temperature is increases, resistance is increases. When temperature is decreases, resistance decreases. So there exists one state at that temperature the resistance becomes zero, and that temperature is known as a critical temperature. So materials which exhibit such a kind of properties are mercury, zinc, and tin. These are the examples of the material which possess superconductivity. The temperature at which material's electrical resistivity drops to zero is known as a critical temperature, and we denote it by the symbol Tc, capital T suffix C. And thus, the superconductivity is a flow of electric current without resistance in certain metals, alloys, and ceramics at a temperature near about absolute zero. Let us take the example for the aluminum. The temperature is about 1.2 Kelvin. You know, 1.2 Kelvin, that's very low temperature. 0 Kelvin is equals to minus 273 degrees centigrade. Means 1.2 Kelvin is 74 point something. Okay? That much minus 200 and something temperature. So that much too low temperature is there. Okay. So let's move on to the further topic of discovery of superconductivity. So superconductivity was first discovered in 1911 by the Dutch physicist Henk Cameron Ons. So Ons had that a cold wire resistance would dissipate it. This suggested that there would be a steady decrease in electrical resistance, allowing for a better conduction of electricity. At some very low temperature point, scientists felt that there would be a leveling off as the resistance reached some ill-defined minimum value, allowing the current to flow with the little or no resistance. Ons passed a current through a very pure mercury wire and measured its resistance as he steadily lowered the temperature. Much to his surprise, there was no resistance in a mercury at 4.2 Kelvin. Okay? So as you can see in the graph, at 4.2 Kelvin, the electrical resistance, that is the opposition of a material to flow of electric current through it, vanished. Means it offers zero resistance. Okay, so that gives an extremely good conductor of electricity that is known as a superconductivity. So let's move on to the further topic of properties of superconductor. So first property of superconductor, as we know, is electrical resistance. We have literally discussed it. So virtually zero electrical resistance is offered by the superconductor. Now next comes the effect of impurities. When impurities are added to a superconducting element, the superconductivity does not losses, but its critical temperature is quite lower. Okay, the every material, though it has few impurities, it possesses superconductivity. But definitely, compared to the pure material, its critical temperature value gets lower. Effect of pressure and stresses. Certain materials exhibit superconductivity on increasing the pressure in superconductors. The increase in stress results in the increase of the Tc value. The Tc, that is critical temperature. Okay. So next further property is the isotope effect. The critical or transition temperature Tc value of a superconductor is found to vary with its isotopic mass. That is, the transition temperature is inversely proportional to the square root of isotopic mass of a single superconductor. Tc is proportional to 1 upon under root m, where m is an isotopic mass. So that is all about the effect of isotopic. Okay, that is all about the isotopic effect. So critical temperature is also termed as transition temperature because at that temperature the transition from normal state to superconducting state occurs. Okay, so that is why depending on the situation it is also named as a transition temperature. Now for the next property is magnetic field effect. If a strong magnetic field applied to a superconductor below its critical temperature, the superconductor undergo a transition from superconducting state to the normal state. Okay, so if a strong magnetic field is applied, its superconductivity gets losses. So the minimum magnetic field required to destroy a superconducting state is known as a critical magnetic field. That is Hc. You know that magnetic field is defined is denoted by capital H. Okay, its unit is Henry. So capital H is for magnetic field and C is suffix for critical magnetic field. Okay, so let me recall it. If a strong magnetic field is applied to a superconductor below its temperature below its critical temperature, the superconductor undergo a transition from superconducting state to the normal state. Again, it will come back to its normal state. Okay, the minimum magnetic field required to destroy a superconducting state is known as a critical magnetic field, and it can be given by the equation Hc is equals to H0 in bracket 1 minus T by Tc whole square, where H0 is the critical field and T equals to 0 Kelvin temperature. Okay. So now further property is critical current density and critical current. So critical current density can be defined as the maximum current that can be permitted in a superconducting material without destroying its superconducting state. So it is the maximum allowable current that can be permitted in a material without destroying its superconducting state. That current that is known as a critical current density. The relationship between critical current and critical magnetic field can be given by IC is equals to 2 pi r Hc, where r is the radius of superconducting wire. And the relationship between critical current density and the critical current can be given by Jc is equals to IC divided by A, where A is the area of superconducting wire. You are very much aware about the relationship between current and the temperature. If the flow of current increases, the heat energy generated inside because of the resistance increases. By the law, you know about the Joule's law, H is equals to I square RT. So by the law, because of with the increase in a current, the electrical resistance, few minor electrical resistance is there, then it will develop a heat inside it. Because of that, its temperature will rise above the critical temperature, and thus it will lose the superconducting stage. Okay, that's the relation. So the minimum amount of current required to lose the maintain that superconducting state is known as a critical current density. Now, last important property is persistent current. The steady flow of current in a superconducting wire without any potential deriving is known as a persistent current. Okay. Now, in this video, now in the next video, we will learn one more and most important property of superconducting material, that is Misner effect, and important factors to define a superconducting state. That's it for today, guys. Thanks for watching.